Morning, what is up, everyone? Let me shuffle around windows here. Ooh. Okay. I had the sound. I don't know if it was gonna fit back. That again, hopefully. Right. So, I think we're good to go now. So welcome, first of all, thanks to anyone who's watching. If you are new and don't know, my name's Tim. I go by Foamy Guy on GitHub and Discord, and I usually stream around the time each week working on stuff related to CircuitPython. You know what CircuitPython is, you can find out more about it at the main website here, circuitpython.org. This is basically a version of Python that runs on tiny computers called microcontrollers. There are many different shapes and sizes of microcontrollers. There are many different ways to program them. CircuitPython is just one of them, and if you choose to use CircuitPython the way it usually works, you plug your microcontroller into the computer with a USB cable. It will show up like a thumb drive, and you can edit a Python code file on that thumb drive. Then when you save it, the microcontroller, the little chip here that's on the device, will actually execute, like interpret and execute that Python code for you. And the code itself can interface with whatever else you hook up to it. So some of these devices are very general purpose. You can hook up whatever you want to it. It's kind of like the base that you can use to build something else. Others are more purpose-built, like this little macro pad here has keys and a knob and a display, and less ways for you to hook up other random bits and bobs. So kind of the full spectrum of purpose-built through really general purpose on these devices. Like I said, CircuitPython.org, you can learn more about it there. Just link to Adafruits. As always, Adafruit is a hardware and software company based out of New York. They make CircuitPython possible by paying a team of folks to work on it, including myself. So if you would like to help support them in CircuitPython, as well as some other open source software that they do pay people to work on, there's also Arduino drivers and all sorts of other things that are unrelated to CircuitPython that they pay people to keep maintaining and keep improving and stuff like that. So if you would like to help support them, you can do so by purchasing hardware at their website, adafruit.com. We are getting back the new bits and bobs in the shop as well. So a couple of new products over the last week or two. There's an I/O expander, and then these line of different colored white LEDs. So these are electrically, they sort of look like neopixels as far as the code is concerned, but instead of red, green, and blue on the pixels, my understanding is that these have three different colors of white. So there's kind of like a natural white, a cool white, and a warm white, if I understand it correctly. And then because it, is seen as a neopixel from the code, you can also sort of blend, mix and match those together. I haven't picked these up yet, but they are new, and I understand there's more form factors coming for the people who do think they're cool. So thanks, as always, to anyone who does support the open source work that they do by purchasing hardware. I am joining today back on the same thing that I worked on last week. So for anyone who caught last week's stream, I did pop in a little bit earlier than normal, so I don't know how many folks saw it, but last week we were working on the Teenage Engineering ting EP-2350. I just pulled that up. Let's see. Their website is a bit. I don't care so much about their website. Like a lot of weird scrolling and well, to just go to the thing you want, basically. But yeah, this is a device that I was messing with last week. I don't remember if I had the camera set up last week. I don't think so, but I'm not sure. But last week we were in the very, very early stages of getting it working, so not a whole lot actually did anything last week. But this week I am much further along with it. I do, so if I recall correctly, where I left off on last week's stream, we had nailed down a bunch of the pins, like the I2C pins, the I2S pins, and I started trying to get some audio to happen, and we got maybe like a blip or something when it connected to the line, but that is really it. And so this week I have gone a lot farther than that. I got the audio working, so I was able to get MicroPython code that could output audio over the 3.5 millimeter line. I think I eventually also got the MicroPython code for the microphone input, I believe. And then relatively quickly after getting sort of the minimal, like just get audio to do something, like it wasn't sounding perfect and it wasn't, it's definitely had its issues, but it was like audio came out and audio went in, and that was kind of like good enough proof to keep going. And so the next thing that I tried to tackle after that was getting CircuitPython on it, or I should say in between there actually was figuring out the rest of the pins. So there are buttons on this device here on the side. There's this little knob, which is a potentiometer. There is the handle over here, and the handle actually has two different buttons inside of it. There's one that is sort of pressed when the handle is fully out, like it is right now. And when you start to press the handle, it releases that button that's in there. And then there's another one that's at the very bottom, the very apex of this press here. So you can kind of feel it at the end. You get to the end, and then you can click it just a little bit. There's a tactile switch in there. So there's two buttons on the handle, the potentiometer, the three buttons on the side, and then there are 8 LEDs. So there are 4 white LEDs, and there are 4 red LEDs. Back off because actually do something besides just demonstrate the LEDs for right now. So that is this device, and I did figure out all of the pins so that I could drive all those. I got a CircuitPython board def for it. For anyone who happens to have this device, if you want to play along at home, the PR is 111136, which has not only the board def for this device, but it also has the I2S duplex support, although it is still in review. The API can change as always. But it essentially lets you not only use this device with CircuitPython, but the thing about this that is new for CircuitPython is that there is an audio codec chip on here that handles both input and output. Well, I don't know, it's possible we've had chips like that before, but we've never supported it in CircuitPython. So in CircuitPython, traditionally we had I2S in, we had I2S out, and each one expected to use the clock pins as well as the data pins. And it was not set up so that you could have sort of like one I2S in and one I2S out, and they could share the clock pins. That was not a thing that really existed before. They would each try to grab the pins, and whichever one came second, it would be like, uh-oh, I can't get the pin because they're already claimed. And so this duplex support adds this new concept of clock follower, which is, like the name hopefully suggests, is making it so that that object, when you initialize it with that to true, instead of that sort of wanting to drive its own clock by claiming the pins and doing whatever it needs to do with them, instead it will just watch the pins So it will sort of follow along with whatever the clock that's already running on those pins is. So with that, you can set up code sort of like this, where you have one I2S object, I2S in. Or I guess I didn't start from the top. You have one up here, which is I2S out. It can claim these pins and it can act in source mode, so it's going to drive the clock. And then this one, I2S in down here, it is initialized with the same pins. This is out of date because I changed this to WS. But it gets this clock follower true, and because it has clock follower true, instead of trying to claim those clock pins, what it will do is it will just sort of watch along, and as they flip-flop back and forth, it will do its audio thing, sending its audio where it needs to go, and so forth. Which is very cool for this device in particular, because it's kind of the sort of the primary thing about this device. So as I understand it, you know what I should actually try to find is the product page. I kind of want to see more like it in its natural habitat, so to speak. So I think they sell it as an add-on for this thing. I mean, their website, like, it's very pretty. It looks cool. I do like lots of the artwork that's in lots of these photos, but it's very overwhelming as the website. And the scroll gets messed up, and it's like just a very long poster. It's unclear if things are interactive or not. Like, okay, 388. So this is so this is the microphone that I have, and then it is, so the way they sell it is kind of an add-on to this sort of like calculator looking, it's a sampler, live loop. It's got a high level. Just scroll past it, was that it? A live loop performance mode and onboard bass and lead synth, massive reggae dub and dancehall sound library, pressure sensitive dub siren, and 8 user remixable artist tracks. Not 8 users, but 8 tracks that you can remix from top producers. The EP-40 rhythm is complete rhythm and bass system. I will freely admit I'm like very new / don't really know much about the audio gadget world. So a lot of this stuff, it's been around for a minute, but I just don't know much about it. So I still am a little unclear. Is it like it's a looper sampler? It can like run its own beats or whatever, something like this. I'm imagining, and you configure it with all the controls that are here. And so they sell this microphone, which would plug in. Presumably there will be a 3.5 input on this thing. Maybe we go to this one. Oh no, this is the ting though. Rhythm, where is there? It's okay, it's tiny in the middle there. That's interesting. But it's sold out. Getting inside this little microphone. Oh, wow, it's so thin. Wow, I did not realize how thin it was from the front. Interesting. Oh, that's cool. This one even has the screwdriver on there. Let's say the size or something. Oh, it does. Yeah, Philips 00. Cool. I wonder what's inside one of these ones. After getting inside the microphone, I'm kind of interested to play with more of their hardware. And I do actually have another thing that was made by them that I will hack on a little bit next, but it's not exactly what I mean when I say more of their hardware either. A layering machine. Okay. Got the mic plugged into this input here. It would be kind of cool to play with one of the bigger ones. One's out of stock though. I don't know if there's a newer. That was it, I guess. I don't know if there's a newer one or what. Koi 2, is that a different thing? With the same sort of rough box and interface. Go to a comic device. Okay. I wonder they're like functional. Okay. Are there functional differences between these, or are they just sort of reskins, so to speak, right? Like all the buttons, they look like the hardware is identical, right? Just different color box and reskinned the interface on the display. Huh. The cool thing is that means these actually are in stock. Just what if you want the? Did I just click buy? No. Actually, here it doesn't say anything about out of stock. Not just on a page where it called that out of stock. Well, the microphones are. Maybe I was on the microphone page. Okay. Anyway, sorry, I don't want to get too far down the engineering rabbit hole. I'm a lot more curious though about their hardware now that I've been inside this one. It was kind of like a pleasure, so to speak. It was a pleasure to take apart, put the back together compared to a lot of stuff. Like it was very easy. Could have been made a lot harder than it was. I appreciate that it wasn't, and so I'm sort of interested in getting more of the hardware to play with. But to get back to the point here for now, we have CircuitPython running on it, and really what I want to do today is just play with the audio effects a little bit more with what we can do. So yeah, the PR is there if anyone wants to play along. The driver is also out on GitHub. It's not released yet. It's not in the bundle yet, so you got to find it on GitHub. If you search the name under the different repos, you can get to it in a U88L21, which is the chip that happens to be on that Teenage Engineering EP-2350 microphone. And so what I was playing with right before I started was plugging in, what do they call this? A low frequency oscillator. Plugging in oscillators where you would have a number ordinarily. So like the granular pitch shift here has just a number that is 12 in this case that's getting passed to it. But it is a type, what do they call that? Block input? Synth-IO block input? Maybe if I install the newer stubs, would I get? But I think you need to know, is it like dev? Thing is, though, we need not even just the released version of the newest stubs, because I think that would be targeting the supported release, not the dev mode. Is it just dev or? know how you target like pre-release one. Once upon a time I knew this, but can target just an individual one, but here's where I was figuring out how this LFO thing works. Pretty sure there's a way to just say like the newest pre-release as well. Might take 90 a minute to catch back up, or it just might still not work for some reason. But in any case, the semitones does take one of these synth.io block inputs, which let you pass one of these other objects. A synth.io block input, which means it can be any of these types, math, LFO, float, basic numbers, or none, treated as 0. Math. Interesting. Not quite what that would do exactly. I guess you could, I mean, it would depend on what you set it up to do. Be cool to have a demo of that one doing something specific. But this thing is cool because I could set this microphone up instead of, so what I had before was sort of one effect that would go pitch up and one effect that would go pitch down. But with this LFO, one of them does this sort of oscillation thing, so I can show you, I think, if this is going to actually all work. So it's running on here. Oh, I'll do this part in the frame so you can see the way this interface works a little bit. So this is set up to where the middle button here will cycle through the white LEDs, and then for each one of those white LEDs, it maps to the red LEDs up top, and those represent the 4 different effects that it can do. So this is like cycling through, and then this button will turn on and off the effect. So there's 4 effects. You can cycle through, turn each one on or off. So if we have that one on only, then that will be the only effect it does. And if I go over to here, I think I can theoretically
check. But now if I talk like this, you can get this back and forth synth semitone up and down situation going on.
Hopefully that worked and was not ungodly loud or anything. It does look like it's got some background fuzz or something. Hopefully that was not too terrible. But I can do the same thing. I can record it in here, and it does the whole up and down situation. Turned my volume off a while ago. Which is pretty cool, and I'm curious to set up some similar things. So for one thing, can I just use that same LFO? So this is kind of like my first time really messing with these these LFO things, so I'm not exactly sure what the rules are, how it works all the way, so I don't know. Could I just, well, I suppose I would not want to use the same one for this is the problem, is it? Yeah, no, we need another one. Make another one. Let's go, we can keep the same one, but the scale is going to be different, so it wasn't too loud, but my internet is jittery, so the effect is compromised. I can filter that too. I got you. Yeah, I will say it does start to sound, it does, especially towards the end, it sounds a little bit, I mean, jittery is a good way to put it as well, honestly. It does start to get skittery towards the end. If I understand correctly, I could raise the raise the density here, and it would smooth it out towards the ends. But I kind of like the, it's like a robotic sort of thing on the edges, which is kind of fun. And what's up, G? By the way, it's nice to see you, my friend. Hope for the best for your internet there. So for Freeverb, we have the room size, which can scale from what? So it's 0.75 is what it's set to. Wonder it can just go from 0 to 1. Okay, so let's do scale 1, and then this will oscillate over 2 seconds if I understand this part right. We'll call this the reverb LFO, and we will stick it in for room size. Actually, do I want to go down to 1? Yeah, let's let it go down to 1. Well, it's not going to be able to go negative, is it? It's going to be able to go negative. Yeah. Actually, we need to use like phase offset or something, but I'm not sure the right way to do it. Good absolute value. Because we have that math thing. There's a practical use of the math thing. I mean, it's practical, sort of. I'm pretty sure there's an argument here that would just do it for us, but offset? Or, no, offset's what we're using. Offset 0. Offset 0. Oh, so I guess what we would want to do is offset to 0.5 and then make the scale 0.5. And so we would go, yeah, between 0 and 1. Yeah, okay. That's what we want to think. So then that's there, damp. That's fine. Okay, so let's save that. And that is on reverb. That is the third effect down. So if I go third and turn that on, I want to be able to hear it as well, so I'm going to capture it this time. In fact, what I'll do is I'll capture it and then I'll play it back to where y'all can hear it as well, I think. Yeah, let me do it that way, which I think is easier now because this is showing up. I could have been wrong. Oh, no, it is. Okay. It's showing up as this. I can grab this and go testing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This, and then I think if I testing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. Testing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, you can definitely hear the back and forth in the sort of like reminds me of a symbol. Oh, yeah, the camera does this sometimes. Can I fix it with this? No. Notice that before. I actually incorporated that effect into the camera, the Pi camera guide from a couple of weeks back. Luckily I can just restart it and that fixes it. Unfortunately, it does pop this window in front, which is a little annoying. Okay, that's kind of cool. I think it would be cooler to not go all the way down to 0, probably. So, one thing that's weird though, well, we could sweep, I guess, we could sweep from, do this. We go 50, like 0.5 to 1.0. Yeah, so it's probably subtle. Testing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 21, 22. Testing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 21, 22. Just skip 20. 18, 19, 21, 22. Okay. Yeah, it's very subtle. I don't hear it nearly as much this time. Maybe that one's not... Maybe that one's not actually the best to have on the oscillator. It was more apparent before. But then when it's on 0, it's effectively not adding anything. I suppose it's not the end of the world, but... What does it do if we speed it up? Low frequency though, I wonder what's like the fastest it can go? It doesn't really say anything about that. If we tried like half a second, is that 7, 8, 9, 10? Testing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think we need as long that time. Testing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I didn't, I never turned the effect back on, which I think I maybe didn't do last time either. Testing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Testing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
That was the wrong effect. Reverb is on 3, so I had just turned on effect 2 instead. Testing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Testing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I want to check this one again since I don't think I actually turned it on. I'm not sure if this really worked though. I mean, maybe it did. At the time I felt like I could hear it, but I did not necessarily hear it oscillate. But maybe it's just going so fast that it doesn't register. So I was on what? 0.75 and then 0.25. Okay, and then yes, I have to actually enable. Oh, otherwise it won't do anything. Testing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Testing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Yeah, it does definitely oscillate there. I do kind of like that. That's a nice touch. It's like not super noticeable. I mean, you can hear the reverb a lot when it's at the highest, but the oscillation is not super noticeable. But it's kind of a nice, like, sweep back and forth, I think. Okay. Let's try one on chorus and see. So here's what the default chorus does. Here, I'll back and try to remember to actually. You want to turn off this one though. That should be the default chorus. Default chorus. Testing 1, 2, 3, 4, 5, 6. Default chorus. Testing 1, 2, 3, 4, 5, 6. Very subtle, honestly. It kind of sounds a little bit like the reverb. One thing is because, well, the granular pitch shifts aren't on. I was going to say because we're using density here, that does give it a little bit of a chorus effect. But those are not on, so that should not be affecting it. Yeah, I think these are just really conservative. It's a lot more noticeable if you bump some of these up. So why don't we say this is the max delay. And then why don't we make the actual delay, so I want to oscillate between let's say 350 on the low side and then 750 on the high side. So in order to do that, I need to know halfway between them. So there's 400 between them, 350 to 750. Which means 200 more. 550 is the middle. And I want to oscillate by 200. Go back to a 2-second period. But then we would also put this here. Hopefully that's supported. Actually check. Okay. Now turn that on, which is effect number 4. Chorus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, it's definitely a lot more full. Chorus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Interesting. Okay. Almost sounds like an echo at that scale. Okay, let's go a little bit. Let's skew a little bit on the faster side. So let's lower the max maybe down to 550. Let's make the offset 350. Yeah, so then we're going 150 to 550. Testing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Testing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Interesting. Testing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Became a lot more subtle. I'm surprised at how much more subtle it became. There's like none of the sort of, or there's a lot less of the echo. Oh, well, that was yeah, that was 550. Go 550. Not entirely sure why there's a max and a delay. Truthfully. Let's read up on it. First one. Why is there this? The maximum time that it can be in milliseconds. The current time in milliseconds must be less than the max. Okay. I mean, they do exactly what they sound like they would do. I just don't know why you would need a maximum when you can set the one you wanted to top out your oscillation early or something. But I feel like you could probably do that somehow with just this and the math thing. Okay, anyway, it did start running. Let's try this one. Put the effect on. Testing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Testing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, interesting. That one's kind of cool. It starts to sound a lot like free verb. Honestly, what if we turn them both on? So free verb is number 3. Testing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Reverb and chorus. Testing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Reverb and chorus. Okay, yeah, it's a little crazy there with them both. And then what if we also do the trifecta here? So that should be pitch shift and reverb and chorus all oscillating. I think they're at different rates though, right? Yeah, reverb is at 1 second, and pitch shift and chorus though are both on the 2 second. I wonder if they'll be locked. Would it be worth trying to like set them opposite? Maybe. I think there is a start offset. Maybe let's try it first. Hold on, I want to delete this. Okay. Testing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Pitch shift, chorus, and reverb. We might have flew too close to the sun, but that's actually really cool. Wow. Okay. Let me try. What if we take the reverb out? What if we just go only chorus? So reverb is 3, I think. So we turn that one off. It's a little hard to see on the camera because the lights bleed over. But the third one is actually off now. It's not just dim. It's off. It's just getting bleed in from the other two. We could change the code to use WM, but could we? No. Well, no, we can't. We can't except for one gotcha, which is that the top LED here and the top LED here, the top white one and the top red one, they share a PWM slice. So I think if you PWM it, they're both going to turn on, or maybe you just can't do them at different rates. Maybe it's fine as long as maybe you can turn them on and off independently, but you well, but that is running them at different rates. That's running one at 0 and one at maybe we should test that. That might be a good thing to do. Yeah, in any case, I want to try this one. So this is with the pitch shifting and the chorus oscillating, but no reverb. Testing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Pitch shift and chorus.
Tester 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Pitch shift and chorus.
Nice.
Tester 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Pitch shift and chorus.
I could see something like this being a torture test for audio for speech to text, right? Like, I'm sure they're probably training that way already, right? Instead of like, you get it to working by training on clean audio, but then you get it working like in the real world by training on messed up audio, because the real world doesn't contain much clean audio. Truthfully, right? Unless it came from a studio, it's probably not clean. This kind of effect, I don't know, that would be useful. You could maybe use this kind of effect if you didn't want your voice to be transcribed by something like that. Yeah, this one is cool though, by the way. I think this one is way cooler without the reverb.
Tester 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Pitch shift and chorus.
The background wave laser reaction thing that's going on is it's still there, but it doesn't completely eclipse the speech. It doesn't make it impossible to hear the speech, basically. Whereas with the reverb, it really kind of did. We could always bump down dampness, or also use a smaller mix as well. I think the mix is going up to 1, or oh no, each one actually has its own mix. But the reverb actually has the lowest of the 3. The reverb's mix is 60%. Okay, very cool. What are the other ones of these? So again, I'm like relatively new to audio. I've played with some of these now because I've made a few different audio projects in a row here, but I'm not sure that I've played with all of them. So let's see. There's manual pitch shift is the new one. So this one, multi-tap delay, I don't think I've done. Create a delay effect where you hear the original sample playing back at various times or taps. Yeah, let's do this one. I want to see what this is. I don't think I've played with this. So let's change out slot number 1 because right now slot number 1 is just pitch up. It's not doing any kind of oscillation or anything fun. I mean, it's fun. It's fun. Like helium sounding. Yeah, so let's start with static first. So some of these, we actually have this common thing for. So this takes a tuple which contains a tuple. So how does that work? Positions and levels. The position or position and level of delay taps. The position is a number from 0 start to 1 end as a relative position in the delay buffer. The level is a number from 0 silence to 1 full volume. If only a float or integer is provided as an element of the tuple, the level is assumed to be 1. When retrieving the value of this property, the level will always be included. Weird. This feels like it should be more than one property, potentially. So if I'm reading that, it's kind of like the position. So 2/3 from 0 to 1. So we're starting 60% of the way through the delay buffer, which is 500 milliseconds. The level is 0.7. Then I don't know why we would have the extra 1 there. Okay, anyway, we can see what it sounds like. So this, I'm going to give it its real name though, multi-tap delay. And we're going to find where it's broken because of pitch up, and we're just going to cheat and swap that right in. Okay, so now the first effect, the top one should be, oh, this still has pitch up. Okay, we want to go here. That is effect number 1. Turn that on. Still prints the wrong thing because I didn't actually change the string. Let me delete this. Testing 1, 2, 3, 4, 5, 6. Multi-tap. Interesting. Looks like it's gonna be some kind of echoing situation. Testing 1, 2, 3, 4, 5, 6. Definitely. Okay. I'm curious. What happens if we also do the pitch shift oscillator. Testing 1, 2, 3, 4, 5, 6, 7. Pitch shift oscillator with multi-tap. But a little bit too much stuff going on. Main audio is kind of choppy. Let's retract it. It's honestly, it could just have been me mumbling, and I think there is a what do you call it? A noise gate that could cut me off if I start to mumble. Yeah, thanks for that heads up here. Let me just more myself a little bit. Chunk that up a tiny bit and try to remember not to mumble. Okay. What other ones of these do we have? Shift is similar to granular pitch shift. It just does it a different way. It does sound a little bit different as well, so theoretically we could play with that. It would sound a bit different, but not, it's like, I don't know, you kind of, it sounds different. Like if you run the same effect through both, you can tell that there's a difference if you listen to them back to back, but it's not going to produce like a meaningfully totally out of left field different thing or anything. Free verb I played with a little bit already. I think so. This one, so there is audio speed, but I think this one technically it's not really meant for this. I did play with this one a little bit at one point, and it does sort of work as a pitch shifter, but I think it's not meant for that. Relic S.E. Cooper. Let me know a little bit more about this one. This is for like if you need to change the rate because you have a different thing that's expecting a different rate. As I understand it, not necessarily just trying to change the pitch. Or the resampler, I guess, is the new one, which can help you change the rate, I think. Maybe I don't have a good grasp on when you would use the speed one, but it's not for pitch shifting because you can end up with gaps. Although the gaps could be interesting as well. If you're just trying to make something that sounds weird or interesting, you might play with it. Okay. I think that's mostly all of the audio ones. There was filters, so there's distortion. Filter. Phaser. Process through a variable. Interesting. I don't know what phaser does, so it might be fun to play with. Turn that one off because it is a little bit overwhelming. These don't show defaults, but oh, here we go. Okay. 1,000 feedback. Okay. It's tough to say really. I don't know. I don't know what that one's gonna do. Phaser, so let's swap that in. Actually, the first one, turn that on. Testing 1, 2, 3, 4, 5, 6. Phaser.
Testing 1, 2, 3, 4, 5, 6. Phaser.
Interesting.
Testing 1, 2, 3, 4, 5, 6. Phaser.
It's like it put it through a tunnel. Around the moon now or something. Weird. Okay. What could we what if we passed, what could we pass? Which one should we pass an oscillator to? Stages. This takes an int, so that's a number. The number of all pass filters. Not sure what that means. So the things that can be oscillators are the mix, which that we're not going to mess with. That's just like how much the effect is in or not. The feedback can, which is the amount that the previous output is mixed back in. Interesting. Starts at 70. And the frequency can as well. Okay, let's try some for those. Let's make a feedback LFO that goes, so this is 0 to 1, it looks like. Doesn't actually say though. Let's do the top half again. So centered on 7.5 and then 0.25 like that. Feedback. Testing 1, 2, 3, 4, 5, 6. Feedback oscillation.
Testing 1, 2, 3, 4, 5, 6. Feedback oscillation.
Like the tunnel and an echo also. Tunnel and echo together. Interesting. Okay, what if we do a frequency also? And this I really have no idea what to expect. What the frequency is going to do. So it starts, default is 1000. So I guess let's sweep from 1000, why don't we just do plus or minus like 300 and see what that gets us. I'll turn this on. Testing 1, 2, 3, 4, 5, 6. Feedback and frequency oscillation.
Testing 1, 2, 3, 4, 5, 6. Feedback and frequency oscillation.
Okay. I want to try also with pitch. Turn that on. Testing 1, 2, 3, 4, 5, 6. Frequency, pitch, and feedback oscillation.
Testing 1, 2, 3, 4, 5, 6. Frequency, pitch, feedback oscillation.
That's fun. It's another one where it's like you could use, I think you could use this kind of like to try to get around text-to-speech. If you're trying to have a recorded message that a human could make out, but it would be really hard for a speech-to-text thing to do, you could probably string together a bunch of effects like this and create something that's difficult until stuff gets trained on it, in which case it would still be able to understand it, I think. very fun. That one's cool. What else do we have here? Phaser, that's the last one. Okay. Interesting. Okay. It'd be cool to look around for some more. What are some more like classic pedal effects and stuff? Like, what are some more effects that we don't have yet that we could add? I wonder. I'm still brand new to this whole audio world, so I don't know what's out there. I know there's like a whole world of pedals that do all kinds of insane stuff. And more sort of like computer-based ones as well these days. But to folks like the older analog stuff, so I'm curious what other effects there might be that we could try to create digital representations of. I think that's maybe going to do it for today. So that's really the main thing that I wanted to do today, was just give sort of the progress update where we're at with the ting, since I started that last week. So if anyone caught the first half of that, where I was first fumbling around in MicroPython trying to figure out the pins, I just want to give the update there that we made it through that. We got the audio working, we got CircuitPython working. There is a guide in the works. I'm working on a guide for this. I will probably finish it next week, and then it'll go through moderation, so maybe come out next week or maybe the one after. It depends, and we'll also have to wait on the PR because it's got this build of CircuitPython and stuff, so we'll see. Yeah, I don't know. It may be bumped a little bit further out, even still, but there is a guide in the works. So for folks that want to do this and be able to follow along with something instead of just be on your own, that's coming as well. You keep an eye on the learning system; it will be there eventually. I think that's all for today. So thanks everyone for watching. I should be back on Tuesday over on the A3 channel on the deep dive there. I don't know for sure what I'll be working on just yet, but I do know, sort of broadly, generally speaking, I am interested in getting back into the Pico game world some more. So I took a bit of time working on a bunch of different audio things, the audio file writer and the I2SN and the duplexing and granular pitch shift. So I've been in audio land a little bit. One of the things I do want to for sure get back to is that Pico game framework. And I know CircuitPython Day is coming up, and the last few years I've done a game jam stream on that day, which I will do again. And I think this year I will definitely be using Pico games. So I'd like to get a little bit more tinkering with it under my belt before then, because I'll plan to try to make something. I'll figure out a game to try to attainable goal for a game to try to work on during the stream on that day. So that will be one thing I'm getting back to. I don't know again if that'll be on Tuesday that I'm playing with it, but broadly speaking, that's going to be on the plate coming up is Pico game stuff. So I think that's it for now. Thank you to everyone for watching. I hope you all have a wonderful rest of your Saturday and weekend. So long, farewell. Thanks for watching, and I will catch you next time.